Hello, everyone. So we're back with balancing chemical equations. This is activity one. Well, there's actually only one activity in this experiment. And for this experiment, we're going to need our uh, our basic chemistry modeling set, which I've already set out here. So basically, you're going to have these red pieces, and you're going to have 8 of these, 5 of the green, 4 of the yellow, 4 of the blue, and 20 of these white prongs. And what we're going to do with these is look to, of course, as the experiment name would have it, look to balance some chemical equations. So what I've done first is I've taken my balancing equations map that I have here. Flip it upside down so you guys can see it. And what I've done is I've listed the 5 different color pieces that I have, starting with blue, red, green, yellow, and white. And I've taken the chemical symbols for each reactant that I have for my first equation, and I've listed them up here. As you can see, I've left the coefficient blank, and I've also taken the liberty of putting the red pieces to represent oxygen and the white pieces for hydrogen. All right, and so the first thing we want to do is look at the entire equation as it's written. So here we have hydrochloric acid and NaOH, which equals to H2O and NaCl. The way this chemical equation is written, I could already tell that it's already balanced in its true form. So what we're going to do is look to build the pieces. As you can see here, as I've indicated before, this is an oxygen molecule, and these white pieces represent hydrogen. So as you can see here, that's 1 oxygen, 2 hydrogen, or as you would say, H2O, which represents water. So we're going to finish out creating the rest of the equation so you guys can see it in a model. So we'll be right back. All right, now as you can see here, we've finished creating our models of each reactant and each product. The one I touched on before, I had the H2O model already created. Now we have our hydrogen and chloride model, and our sodium with our oxygen molecule and our hydrogen. And over here we have our sodium and our chlorine molecule. So what we're going to finish doing here is we're going to list the number of atoms on the left side of each of the elements and the number of atoms on the right side. All right, now that we finished, as you can see there, you have the same number of atoms on the left side that you do on the right side, and vice versa. So that's how you know that this chemical equation is balanced. So for your coefficients here, they would remain 1, so it's really not necessary to put a 1 in front of it. So this here would be our finished balanced chemical equation. So we're going to move on to the next one. So we'll be back. All right, we're back for our second chemical reaction. In this particular one, we're going to be looking at uh, calcium hydroxide plus hydrochloric acid, which is going to give us calcium chloride and water. I don't know if you guys can see that. Okay, so we have that listed. That is our chemical reaction, and we're going to be looking to balance this chemical reaction. So first we're going to start by indicating the color to symbol. So here we're going to use red for oxygen. Okay, blue for chlorine. Do we have? No, we don't have that. So let me wipe this out. Our white's going to be our hydrogen molecules. Let's use green for calcium. And am I missing any? CaCl. Nope, that's it. Okay. So again, we won't be using the yellow. Just red line through that. And let's go ahead and build our models. Here we create water. And then I'm going to need calcium. I'm going to use calcium, it's going to be green. Alright, here we have our calcium chloride. Thank you, Emily. Here we have our water. Hydrogen. Connect those two. We need calcium. Here's what? Calcium. Calcium is blue. Oh, it's green. Alright, here we have our hydrochloric acid. Alright, and then here we have our calcium hydroxide. Now let's go ahead and tally up the number of atoms on the left side. So on the right side for oxygen we have 1. On the left we have 2. See, that's blue. We have 2 on the right, 1 on the left. Green, we have 1 on each side. and then white, 1, 2, 3. We have 3 on the left, and then 2 on the right. So as you can see there, this chemical reaction is not balanced at all. We have a different number of atoms on the left as we do on the right. Now, what can we do to make this chemical reaction balanced? Well, the first thing we can do is write a 2 for the coefficient of the hydrochloric acid and a 2 for our water. Now let's see what that will give us. Okay, now that's an accurate depiction of our chemical reaction. Now let's tally up the number of atoms on each side. So for oxygen, which is our red, we have 2 on the left and 2 on the right. Our blue, we now have 2 on the left, 2 on the right. Green, we have 1 on each side, and then our white, we have 1, 2, 3, 4. We have 4 on the left, and 1, 2, 3, 4, 4 on the right. So there you have it. This is our balanced chemical reaction. So we'll move on to the next chemical reaction. Okay, now we're back with the next chemical reaction that we are going to be looking to balance. Okay, so here we have our chemical reaction. Chemical equation. Now we're going to build it out of the model set. Okay, so here we have 3 oxygen molecules, 1 silver, and I think I wrote this wrong. It's AgNO, capital O. Okay, and we're going to use green for our nitrogen. Okay, so we have our first model. Our second model is going to be 1 hydrogen and 1 chlorine molecule. Here, let me connect those. And then our third model is going to be 1 silver atom with 1 blue atom. Okay. And then our last one is going to be 1 hydrogen, 1 nitrogen, nitrogen is green, and 3 oxygen molecules. Okay, so that's what that looks like. So let's tally up the number of atoms on each side. So for red, we have 4 on the left. Did I count this right? You know what? This model's wrong. Hydrogen and chloride should be blue. So that was actually blue. There we go. Now we got it right. So that's not going to be 4. That's going to be 3 on the left, 3 on the right. 1 blue on the left, 1 blue on the right. Green, we have 1 on each side. Yellow, we have 1 on each side. And white, we also have 1 on each side. So the coefficient for each one of these reactants and the products is going to be 1. Therefore, our chemical reaction was already balanced. So we're going to go ahead and write a 1. And we're going to take a photo, document our work, and move on to the next chemical reaction. All right, so we're back with our next chemical equation. Here we have zinc plus hydrochloric acid, which will result in zinc chloride and hydrogen 2. Okay, so let's go ahead and build our models. We're going to use the white pieces for our hydrogen again. We're going to use blue for the zinc. Chloride, we're going to look to use the green pieces. And are we missing anything? Nope, that's it. Okay, so let's go ahead and build these. So for our zinc, we have a blue, which is just 1 there. And then hydrochloric acid. Okay, so that's what we have there. Zinc chloride. And again, we have 2. All right, zinc chloride, and then H2. Okay, so there we have it. Now I could already see the problem here. I know we have 1 zinc atom on each side, but we have 1 chloride on the left and 2 on the right, and same thing with our hydrogen molecule. We have 1 on the left and 2 on the right. So what coefficient here would we need to add in order to balance out this chemical equation? Well, that's pretty simple. We're going to add coefficient of 2 to the hydrochloric acid, which will give us our balanced equation. There you have it. All right, so now we have 2 on the left, 2 on the right, hydrogen, 2 on the left, 2 on the right. So there we have it, our balanced chemical equation. All Alright, go ahead and take a photo of it and move on to the next. Okay, now we're with the next chemical reaction. We have NaCl BeF2. NaF and BeCl2. Okay. All right, so for this one, let's use Na for red, Cl for white, B for blue, and then F as green. Okay, there we have it. So let's go ahead and build our models. Assistant, where are you?
Yes.
Get back over there.
Okay.
I need you. Okay, so
Coming
Na
right up.
Cl.
Yes, sir.
Put those together. E blue. F is gonna be green.
Okay.
Put those together. BeCls are white. Got it? Okay. All right, so here is what we have written down so far. So as you can tell, this chemical reaction is not balanced. There are 2 red pieces on each side. However, we have 2 green pieces on the left and 1 on the right. 2 of the white pieces on the right and 1 on the left. So what can we do to this chemical reaction to make it balanced? So what we need to do is add 1 green piece to the right and 1 green piece to the left. And the way we do that is by using the coefficient of our first reactant, make that to 2. This is going to be a 1. NaF is going to become 2, and this is going to become 1. Alright, so let's see what that looks like. Okay, so now we have 2 red pieces on each side.
2.
Okay, and then we have 1 blue piece on each side, 2 green pieces on each side, and then 2 of the white pieces, which is our chlorine, on each side. So there you have it. That is our balanced chemical equation. And we're going to move on. Alright, we're back with the next equation. This one, Na Alright, here's our chemical equation. We're going to go ahead and build our model sets. Oh, we forgot our CL. CL is going to be our yellow. And then Na green, CL. Alright, so there we have it. This is our chemical equation. As you can see, it's unbalanced. We have two of our chlorine atoms on the left and one on the right. We also have, besides the chlorine, we have two of the green pieces on the left and one on the right. So what we're going to do to this chemical reaction is add coefficient of 2 to properly balance this equation. So by simply adding another 2 of well, actually one yellow and one green piece, this chemical equation is now balanced. So now we have 3 of the red pieces on each side, 1 of the blue, 2 of the green, 2 of the yellow, and 1 of the white pieces. Therefore, our chemical equation is now balanced. Alright, now we're on equation 7, in which we have magnesium as one of the atoms. And for magnesium, we're going to be looking to use the green pieces. So go ahead and write that in. That's going to be our magnesium. Oxygen's going to be red. And let's see. Let's use let's use blue for Mn. So first for our magnesium, we have 3, and then Mn, which is our blue, we have 2, and 3 oxygen. So what that's going to look like, that's going to look like. And then MgO, that's what that's going to look like. And then our model for Mn is going to be a blue. So as you can see there, this definitely is not balanced. So let's go ahead and do this. Why don't I quickly noticed that we're going to need another of the blue pieces on the right side. So we're going to make that a coefficient of 2 to make that into 2. So now we have 2 blue pieces on both sides. Now we have to work with our oxygen atoms. I'm going to need 2 more I'm going to need 2 more on the right side, and then I'm also going to need 3 of the magnesium atoms. So let's see. This is going to stay 1. Let's turn that into 3. And turn that into 3. See how this works out. Okay. Now that we added our coefficients, I added a coefficient to the magnesium, added a 3 coefficient, that remained a 1. I added a coefficient of 3 to magnesium oxide, which gave me my 3 oxygen molecules and my 3 magnesium molecules. And then I added a coefficient of 2 to give me 2 of the blue pieces. So now what gives me is 3 of the red pieces on each side, 3 of each green piece on each side, Therefore, now this equation is balanced. Let's go ahead and document this. All right, and we'll move on. All right, now we're on equation number 8. CuO2 and CuO. Alright guys, here we only have 2 elements. We're going to be using Cu and O2, which gives us CuO. And right away I can tell that this equation is not balanced, because I already know there's 2 atoms of oxygen on the left and only 1 on the right. Just by looking at this here, looks like I'm going to need another oxygen molecule on the right, and by doing that, it's gonna, if I add a 2 here, it's gonna give me now 2 of the Cu atoms, and I only have 1 here, so I'm gonna make this a 2 as well. So this is gonna be 2, 1, 2 for the coefficients, and this is what this is gonna look like. So that's 2 of the white pieces on the left, 2 of the red pieces, or oxygen on the left, followed by 2 of both the white and red on the right side. And there we go. There you have it. That is our chemical equation. All right, we're back for equation number 9. Here we have CH4 and O2 giving us products of CO2 and H2O. In order to balance this one out, looks like we're going to need an additional oxygen atom on the right side, because we have O2 here. Well, I'm sorry, an additional oxygen atom on the left side, because we have O2 and O2 here, and then an additional oxygen atom on this side. So we're going to need another one on the left, and in order for us to do that, we're going to have to turn this into 2. So now what that did was give me an extra oxygen atom on the left side. So I'm going to have to do this, add another one to the right side, and the only place I can do that is to the H2O. So we're going to make that into a 2. We're going to leave this CO2 at 1, because now that we only have 1 carbon on this side, so we want to leave that 1 single carbon atom also on the right side. We're going to turn that into a 1. However, when we added the coefficient of well, actually no, that C2 of H2O gives me 4 hydrogen atoms on this right side, and I already have 4 hydrogen atoms on this left side, so we're going to leave this as 1. So let's create our models and see if that balanced my chemical equation. So for oxygen, we're going to use red. For carbon, let's use blue. For hydrogen, we're going to use white. Arrows. I need you to add a white piece to the end of that.
Okay.
And then here at O2,
Did you give me 4 because? Oh wait.
let's see. Here we have CO2, and then we need H2O.
Here.
Yeah. All right, everyone. So we know we have 4 of the red pieces on each side, 1 of the blue on each side, and then we have 4 of the white pieces on each side. So this chemical equation is now balanced. All right, now here we are with our last equation, which is our number 10. We have magnesium. We have our hydrochloric acid, magnesium chloride, and hydrogen 2. Just by looking at this, I could already tell that I have 2 chlorine molecules on the right side. I only have 1 on the left, and then I also have 2 hydrogen atoms and I only have 1 on the left. So this is one of our simpler equations to balance, as you can see here. We have 2 hydrogen and 2 of the chloride. So no, I'm sorry, I said that wrong. I was looking at the backward. We have 2 chlorine molecules and 2 hydrogen atoms. So all we need to do is just simply add a coefficient of 2 to our hydrochloric acid to balance this equation out. Okay, we'll make the other ones all 1s. So let's draw up our models and see what that looks like. For this one, we won't be needing oxygen. So for magnesium, we're going to use our green. For our hydrogen, we'll be using our white, and then for our chloride, we're going to be using our blue. Okay, so let's see what that looks like. So magnesium, 1. Here, make me another one of these, just blue and white. And then magnesium chloride. What's that? And then here we have 2HO. Okay, so this gives me 1 magnesium atom on each side, 2 of the chlorine molecules, atoms, and then 2 of each hydrogen. So there we have it. We have our balanced chemical equation. That would conclude our video. Thanks for joining us.